Okay, this video we will look into Serde. Serde is a framework for serializing and deserializing Rust data structures. Um, so this is the documentation for if you go to serde.rs, you will get the documentation, and there's a video also to understand the internals of Serde. So how to use Serde? So in your program, for an example, main.rs, I'm using Serde serialize and deserialize, and Serde JSON because I need to serialize into a JSON, and I want to deserialize from JSON. So that's why I'm using Serde JSON, and any data structure. Uh, Most of the data structures in Rust can be uh, derived, serialized, and deserialized so that it can be easily serialized to a format based on how the deserialization is defined. So in this example, uh, Certe will give serialized and deserialized traits. So just derive it for that, and our main, we can just define the point struct. Uh, so point, we have A as 1 and B as Naveen string, and then Serde JSON to string ampersand v dot unwrap. So this will, let's see what is to string. Serialize the given data structure as a string of JSON. That's what this will do. So we are serializing to a string of JSON for this point struct. Then we will get back a string. That's what J. We can print it. Then we will again deserialize from that string J and get back that point struct again. And we are just printing r dot a. That should be 1. So let's run this. Yeah, we got the serialized version string as well as r dot a is a 1. So you can see data formats. Yeah, different attributes you can use. For example, just want to see skip. Let's see name, rename. Yeah, I want to rename this to hash Saturday rename equals mm, new name. Okay, then let's see what we are getting in this string. So again cargo run. See, now the field name is new name when the serialized string. But when we get back, we are getting back to that assigned to A. So we can give some attributes as well. There are a lot of attributes. That is another thing. And let's see what is skip. Skip. Let's try skip as well. I just want to see. I thought skip is pretty simple. Skip, just skip. Does that work? Yeah, kind of. Let's see. Yeah, it's working. So it just skipped the field A and serialized only B. And when we deserialized it, we didn't get any value. So it's given as 0. Hmm. Okay. I see. Yeah. So that is for that. Now let us go back to data formats. Writing a data format. Yes. Data model. So Serde data model is the API by which data structures and data formats interact. You can think it as a Serde's type system. In code serialization, half of the Serde data model is defined by serializer trait, and the deserialization half is defined by deserializer trait. These are a way of mapping every Rust data structure into a 29 possible types. So these are those types. Each method serializer trait corresponds to one of the type of the model. When serializing a data structure to some format, the serialize implementation for that data structure is responsible for mapping the data structure into Serde data model. So when you, is there an example here? No. Oh, let's see, we have an example here. This is a JSON object. Hmm, okay, I don't know where I read that, but when you do cargo expand will be a tough thing. Implementing serialize. Yeah, the serialized trait looks like this. So when you do serialize on any struct, basically you're implementing this trait. Trait serialize, it has a serialize and it accept a serializer. And with that serializer, it's so generic. It's accept the serializer and return you a result. That's basically the trait is. So if you want to implement I32 for serialize for I32, and as you have, this is the function we have. So we need to implement that. So serialize, generic, still serialize, yes, and serializer dot. So whatever we get through this, we will implement serializer dot serialize I32 if you are implementing for I32. So this is what it's internally calling on the serializer. And let's see. Yeah. So if you see the serializing a struct, this is same as a simple struct and point tuple struct, new type struct, unit struct. Okay. So this is color and we are defining serialize for color, and internally this derive will implement these things on the serializer. Serializer dot serialize struct color, it will be point here. Since we are using point struct, in this example it's color and it's three fields. It has only two, and whatever the object we get back, we will uh, define or implement serialize field on each field, and finally state.end. So these are the things. If you want to expand, I don't have it. Okay, I don't have it. That's okay. So that's what internally happening, and implementing a serializer. So you have Serde serialize error and struct. The serializer trait has a lot of methods, but none of the ones in this implementation are complicated. Each method corresponds to one of the types, the Serde data model. Okay, struct serializer. This string start empty and JSON is appended as values as values are serialized. Okay. By convention, the public API of Serde serializer is one or more two ABC functions such as toString, 2 bytes, okay, toWriter, depending on what Rust types that serializer is able to produce as output. Okay, depending on string or bytes or writer. Maybe if you want to write into a TCP stream, so it will be or file system to writer. So string to string. So this is how it will be. This basic serializer support only to string. So we just convert support only serializer for to string. So we just need to define to string, just any type, and T should be a serialize. And serializer output string new. Okay, define a new string, and whatever we get back dot serialize and pass that serializer. Yeah, so here serialize, yeah, we implemented serialize with here serializer dot serialize I32. For that specific case, so value dot serialize, okay, serializer, so output. Okay, serializer for our serializer, we have to define all these things basically if you are manually doing it. Bool I32, yeah, I32, I64. JSON does not distinguish between different sizes of integers. Okay. So we are implementing basically a JSON serializer. I32, I64, U8, U16, agree, character. We are simply converting to a string, and this only works for strings that don't require escape sequence, but you get the idea. For example, it would emit invalid JSON if the input string contain, yeah, some escaping characters. Yeah, basically we are defining implementing all the serializer traits, functions, methods. Now we get serialization of compound type. To start of sequence, each value and end has three separate method calls. This one is responsible only for serializing the start, which is JSON. Okay, this like this. Starting with like this, it will be, yeah, output is this. Length of sequence may or may not be known ahead of time. This doesn't make a difference in JSON because length is not represented explicitly in a serialized form. Tuple look just like sequence in JSON. Some formats may be able to represent tuples more efficiently by omitting the length. Okay. Maps structs look just like maps in JSON. Yeah, in particular, JSON requires that we serialize the field names of struct. Other formats may be able to omit the field names when serializing struct because of the corresponding deserialized implementation is required to know what the keys are without looking at the serialized data. Okay, we are basically defining all the ones and testing it with a sample data like this, and we get back a JSON. That's cool. Implementing deserializer. What is deserialize? Deserialize, just get a deserializer, and if I32, okay, oh, this is a little more complicated. Visitor is instantiated by a deserialized impl. So struct I32 visitor and implement for I32 visitor value I32 expecting visit I8 I32 and just pass I32 and just return OK value. That's all. Similar for the methods. The visitor trait has a lot of methods that are not implemented for I32 visitor. Leaving them unimplemented means a type error is returned if they get called. For example, map. Okay, why need a visitor? The deserialize, there's no visitor here. This method's job is to map the type into Serde model. Map the type into Serde model by providing deserializer with a visitor that can be driven by the deserializer to construct an instance of your type. In most cases, Serde's derive is able to generate appropriate implementation of deserialize for structs and enums defined in your crate. Should you need to customize the deserialization behavior for a type in a way that derive does not support, you can implement deserialize yourself. Implementing deserialize for a type tends to be more complicated than implementing serialize. Okay, deserialize implementation is even more complicated. Deserializer traits support two entry point styles which enable different kind of deserialization. Deserialization any method, self-describing data formats like JSON are able to look at the serialized data and tell what it represents. For example, JSON deserializer may see an opening curly brace and know that it's seeing a map. Okay. If the data format support deserialize any, it will derive the visitor using whatever type it sees in the input. Okay. If you see this, it will derive map like that. JSON uses this approach when deserializing Serde JSON value, which is an enum that can be represented any JSON document without knowing that what is in the JSON format. Yeah, we can deserialize it to Serde JSON value by going through deserialize or deserialize any. The various other deserialize methods, non-self-describing formats like postcard need to be told what is in the input in order to deserialize it. The deserialize star methods are hints to deserialize how to interpret the next piece of input. Mm, yeah, see, deserialize I did it too. Map is even complicated. Expecting visitor map. Okay. Hmm. Deserialize is complicated. Okay, let's see what is there in the code. So this is deserialize. We are going to Serde derive and derive deserialize. Oh, it's a macro. Let's see what is this deserialize. Oh, it's not pointing. Same thing, yeah, it's a macro. This is how the procedure macro. Okay, while the cargo expand is getting installed, let's go through serialize. So this is inside Serde, and you can just see is basically defining the serialize trait, and these are all examples. Yeah, basically Yeah, it's pretty simple. Serialize, that's all. And serializer is trait is complicated, has type OK, type error. The output type produced by the serializer during successful serialization, that's what OK type. Most serializations that produce text or binary output should be OK. Serialize into IO write or buffer contained within the serializer instance. Hmm. Serializers that build in memory data structures may be simplified using OK to propagate the data structure around. Okay. Yeah, basically they have OK and error and serialize seq. So all the type returned from seq for serializing contents of sequence. So we need, this, this is the seq trait. This is another trait. Basically, OK, error, and serialize element. Yeah, internally it needs to serialize each element. So let's go back. Serialize itself and serializer. So everything, all the maps, the data models, Serde data models created separate type. Define separate type. And I66 example. Yeah, this is what the example we have seen. 64. Yeah, the same code that we have seen in the example is a actual trait from the source code. Yeah, now if we go back to deserialize, this will have the visitor. Okay, trait is simple, deserialize, and deserialize in place, deserialize, those two only. Another deserialize owned. Let's leave it. Uh, yeah, when you are defining deserialize, it needs to implement visitor extended visitor. Yeah, this part is complicated. Data format can deserialize any data structure supported by Serde. Yeah, these are the data formats. And deserialize trait is actually it has an error type. The error type that can be returned if some error occurred during deserialization. And deserialize any, deserialize bool, I32, I8, I16, I32, 64, I18, U8, U16, okay, all the ones. Deserialize string. Yeah, deserialize string, if you see it, it is passing a visitor. So what is visitor? Trait visitor, a value produced by this visitor. Okay, that's what the value. And for example, format a message stating what data this visitor expects to receive. This is used in error messages. The message should complete the sentence. This visitor expects to receive For example, the message could be an integer between 0 to 64. The message should not be capitalized and should not end with a period. Format Serde value. Okay, this is the value type. And we should define expecting. Okay, max. Self.max. Okay, formatter is an example. Yeah, Boolean default implementation fails with a type error. Oh, default implementation fails with a, okay. Default I8 default implementation forwards to I64. Yeah, it's calling I64. What is it? I64. I64 default implementation of I64 is error. Yeah, this features is Serde can be used in non-STD systems as well, like embedded systems. So this code inside this need STD standard library and feature a lock any of this. And so that's the reason you will see the CFG configuration features. Some of the code can run without standard modules. Deserialize is complicated, a lot of things. Okay, I just did a cargo expand. So this is what I did, cargo expand. And the generated file I moved to serde-x.rs. So that's what this file is. So let's see what it has generated. So basically this is our program and this is what cargo expand generated. So the derives serialize. So that's what implemented this Serde serialize for point and serialize. Yeah, serialize. Yeah, this arguments and Serde serializer serialize struct. That's what first called with point as one of the argument and number of parameters fields 1 plus 1 2. Okay, that's what we have, one A and B. And yeah, individually again it's calling on serialized struct serialized field on A, serialized struct serialized field on B, and struct end. Okay, that's clear. Deserialize enum field 0 field 1 ignore on field. Okay, hidden. And yeah, it's created a visitor on field visitor type field expecting formatter. Yeah, deserializer is very difficult. Which is 64 U64 str bytes. Okay, deserialize on field. That will call deserializer as a field, as a parameter, and it's calling deserialize identifier. Okay, field visitor. Type value point, struct visitor, marker lifetime, implement visitor for visitor, type value point, expecting visit sequence, map, and debug. Okay. Hmm. Deserialize is a little difficult to understand. Deserialize for point, deserialize. Okay, some enum struct field visitor has created a field visitor and visitor for field visitor. Each field value field field identifier field 0, field 1, A, B, and ignore here field str. Field 1 option I32 option string. Hmm. Okay, that's what it's created. Okay, let's check further on to string. It has vector string. That's all. Try. We only use our own error type. No need for conversions provided by standard library. Let's try. Okay. Just emit a string. We do not emit invalid UTF-8. Okay. Serialize the given data structure as a string of JSON. Okay, that's fine. How it's calling from Serde JSON. Okay. Um, okay, value is defined as enum, null, boolean, number, string, array, or object. Thus, these many things are enough to define a JSON. Any valid JSON data can be manipulated in the following recursive enum representation. Okay, that's cool. So example, this is JSON from string. It's creating a value. So where is from string? So example, let's see where is from string. Load of feature equal to std, not feature std. So these two are can work without std. This is with std. Okay. What is inside this? Okay, serialize a rest data structure into JSON data. Okay, let's see how they are serializing it. Serializer. Okay, implement serialize. Serializer is IO write and formatter and all that serializer type. Okay, defining all the methods. Object wrapper. Serialize struct. State. Compound. Okay, let's not go there. Let's go this one and see. Oh, here also compound formatter. Similar file defining all the methods in the serializer, implementing those. Begin array value. Yeah. 9. How are they calling reading this? Okay, it should be from string. Lexical read. Trait used by the deserializer by iterating over input. Okay. Next, peak discard. Oh, it has a lot of. It's defining its own read. Positions. IO read. Raw value. Slice read. JSON input source that reads from a slice of bytes. This is more efficient than iterators because peak can be read only and we can compute line column position only if error happens. They're defining read differently. Create a JSON input source to read from IO input stream. Okay. Peak position. Okay. Yeah. This is read. A lot of methods, functions they defined here to support that read. Slice read. Okay, let's then go back to this lexical. Oh, lexical is not a lexical should be here. Okay, so Serde JSON, src raw numbers map lexical. Wow, a lot of lexical mod.rs. The code in this module is derived from lexical crate by lex, which the author condensed into this minimal subset for use in Serde JSON. For the Serde JSON, we care more about reliably round tripping all possible floating point values. Um, okay, more tutorials. Integer parse float from extracted float components. Okay. Oh, JSON Serde serialize into string. Okay, serialize. Okay, just defining and implementing the serializer. Agree. That's not a problem. So, hmm, it's two vector value. What is value? Serialize. Serialize given data structure as a string of JSON. Yeah. Try vector. Try macro role. We only here. It's just for error. Just for error. To strings. Serialize to string. Serialize given data structure into string. Okay, write to write, try into write, into write. Yeah, here it's calling serializer new serial with the writer as sir and value dot serialize. Okay, here it's serializing. Okay, here is what writing. Yeah, this one. Yeah, here it's what it's writing basically. Started calling the serialized thing. This Serde serialize. Okay, that's how it is. From string basically is calling from trait, deserialize, deserializer new, and deserialize. Okay, and try d dot end. Deserialize instance of type T from IO stream of JSON. The content of IO stream is deserialized directly from stream without being buffered in memory. Okay, I think that's all. I can just run. Yeah, I think we have run this before. Yeah, I think that's all I need to cover in this video. We will connect with some other topic next time. Thank you.